Today we will be solving a great circle sailing question, and this is example 4. I have previously put up videos of example 1, 2 and 3. The links to those videos are in the description section below. This solution will be a bit long, so I'll get started, and if you get bored in the middle of the video, just pause it and watch it whenever you're ready. Make sure that you understand each of the stages of the solution before you proceed on to the next. Otherwise you will not get a good understanding of this topic. All right, so let's get started. The topic is great circle sailing, example number 4. The question says calculate the great circle distance, the initial and final courses, position of the vertex from the position x, latitude and longitude is given, to y, and again latitude and longitude is given. One of the latitudes lies in the north hemisphere, the other in the south hemisphere. Both the longitudes are in the western longitude. You also have to find the longitude in which the track crosses the equator, that is 0 degrees of latitude, and the latitude you have to find in which the track crosses the longitude of 010 degrees west. Alright, so we'll go in that order. We'll start with the great circle distance first, but before we do that, we'll draw a figure which depicts the scenario given to us in the question. So now, like I told you, one of the latitudes is in the northern hemisphere, the other one is in the southern hemisphere. Whenever you see the two latitudes are in different hemispheres, draw the pole towards the higher latitude, the value of the higher latitude. So here the latitude in the northern hemisphere is 49 degrees north, and the southern hemisphere latitude is 23 degrees. Because the northern latitude is of the higher value, I have drawn the north pole as a reference. Alright, if the south latitude would have been higher, I would have drawn it with reference to the south pole. Now of course the vessel is going in this direction because we have the latitude sorted, but the longitude is 5 degrees 12 minutes west of x, and the y's longitude is 41 degrees west, 41 degrees 58 minutes west, so it's further west. So I know the shortest distance is going westerly, so that's how the vessel is proceeding. This angle here becomes the initial course angle, and I'll tell you about the final course angle later on. Alright, so let's get started with finding the great circle distance first. Now before we do that, we also have to name the sides of the triangle. So here first we start with I'll erase this, otherwise you guys might get a bit confused. Alright, so here, so the latitude is, this part is the latitude from the equator. So this is 49 degrees 58 minutes north. So px would be 90 degrees minus the latitude of x. Why? Because from P to the equator, here, this distance here is 90 degrees, right? From the pole to the equator is 90 degrees. From x to the equator is the latitude, because latitudes are always measured with reference to the equator. So therefore px would be equal to 90 degrees minus latitude of x. So it will be 90 degrees minus 49 degrees 58 minutes. That would be px. Alright, I'll keep erasing these so that you guys don't get confused and it's not too much cluttered. And similarly for py, p to the equator is 90 degrees. From the equator to y is the latitude of y, which is 23 degrees 1 minute south. So py would be in this case 90 degrees plus latitude of y. Py, you can see y. So p to equator is 90 degrees, and from the equator to y is the latitude of y, which is 23 degrees 1 minute. So 90 plus 23 would give you py, which is equal to 113 degrees 1 minute. Finally, we calculate p. P is nothing but the d long between x and y. So d long between x and y, one longitude is 41 degrees 58 minutes west, the other is 5 degrees 12 minutes west. If both are in the same side, you will be subtracting one from the other. Take the larger value, subtract the smaller value from the other. Here of course it doesn't matter, but the vessel is going westerly. So subtract the two and you get your d long as 36 degrees 46 minutes. And that is the angle P here in the diagram. That is the d long. So the first thing we do is find the great circle distance, which is the distance xy. But to do that, we use the cosine rule. So the cosine rule says if in a spherical triangle the two sides and the given angle between it, that is the included angle between it, is given, you can find out the rest of the values. So you can see here px and py is given, and the angle included between px and py is angle p. All the three values are given, so we can pretty much find out the rest of the values. But right now we are concerned with the distance xy because that is the great circle distance. So the distance xy is the great circle distance. So how do you write down the cosine formula? You write down the included angle first, cos p equals to the side opposite to the cos p, which is cos xy, minus the remaining two sides, cos px and cos py, divided by the sine of the remaining two sides, px and py. So the same px and py come here, but this time they become a sine. Alright, so you write cos p, which is the included angle, equal to cos of the side opposite to angle p, or side opposite to the included angle, which is xy, then minus product of the coses of the remaining two sides, and then in the denominator the remaining two sides also come, they are repeated but with a sine angle. So then cos xy would be, take these values here, right? We need to find out xy, so we need to isolate it on one side, and then this also goes to the other side. So therefore cos xy equals cos p multiplied by sin px multiplied by sin py plus cos px multiplied by cos py. You know these values already, you have found them out. Put the values in the equation. Alright, put the values in the equation. Start getting the numbers from the calculator. You should be getting the same answer that I am getting. Sorry. So you can see, match this value equals this value here, and this value equals this value here. Retain the negative signs if you are getting any, like I have. Finally, you should be getting cos xy equals 0.17488. Take cos to the other side, becomes cos inverse. So xy will then be 79.93 degrees. But this is degrees, I need the distance. How do I get the distance? I will multiply this by 60. 1 degree equals 60 minutes, and 1 minute equals 1 mile in nautical terms. So xy, or the great circle distance, equals to 4795.7. Of course, sometimes these distances value will differ because of the number of decimal places we use. So do not get too stressed about the exact value. If it's close enough to this, then our answer is correct. Now if you ask me what do you mean by close enough, well, it's a range depending on the decimal values. You can see the difference yourself. It will be somewhere between the 10 to 15 to 20 mile range, but I cannot define the range here, but you will get an idea. Alright, once you have got the great circle distance, forget about the distance in nautical miles. For the rest of the question, you will be using the xy value in degrees, 79.93 degrees. This is only for the answer. Next, you find out the initial course angle, ICA, which is the angle x in the diagram that I showed you above. This is the ICA. Alright, how do I find this angle out? So again, we'll use the cosine rule because now you know xy, so you know the two sides and the angle included between it. This time the angle included becomes x, angle x. So you write cos x equals cos of the side opposite to it, which is py, minus cos of the other two sides divided by the sine of the other two sides. Simply put in the values as I have. Make sure you retain the negative signs as I have. Keep comparing the values at every stage so that you don't go wrong. If you're not getting the same values, check your answer because my answer is correct. So you keep checking your answer. Alright, make sure you get the right answer. Compare and keep comparing with my values. Finally, you should be getting cos x equals negative 0.82876. Take cos to the other side, becomes cos inverse. Cos inverse of this angle gives you x 146 degrees. Now this is not the final initial, sorry, this is not the final value of the initial course angle. This is just the angle value that you have found as 146 degrees, but your initial course angle will be measured from the pole. So if I go back here, I should not be calling this the initial course angle. The initial course angle will be measured from the pole, clockwise, in a clockwise direction, right? So if I have got x as 146, that means this angle is 146, but that's not my course. My course is measured from the pole, clockwise direction, to where the ship's course is. So if I say this value is 146, this would also mean, if I put it in the respect of north and south, east and west, if this is 146, how much is this value here? That could be said as 360 minus 146. But if I want the quadrant, then of course the northwest quadrant is 90 degrees, but my value is 146, so remaining is 56 degrees here. So this value is 56 degrees. So this value is how much? 34 degrees. And I am doing a course of south 34 degrees west. So although I can find out the initial course angle by subtracting 360 minus the x value that you've got in this case, I need to find the quadrant. I need to find the quadrant because I will be using this information later on to decide on the position of the vertex. Alright, if you didn't understand how I named it, go back and watch the video again. So the value 146, 90 degrees is in the northwest quadrant and the remaining 56 degrees in the southwest quadrant. But we always measure courses southwest, southeast, northwest or northeast. So in this case I will measure it southwest, and southwest the course is south 34 degrees west, which is also equal to 214 degrees true. That's why my initial course is 214 degrees true or south 34 degrees west. Then I move on to my final course. The final course I will find out by first finding out the internal value of the angle y in the triangle using the cosine rule. I will not repeat how to write the cosine rule. Simply write down the cosine rule here and put in the values. Keep checking with my answers. Retain the negative signs. Negative and negative do become positive in cases where there are two negatives. Make sure you get cos y equals 0.92036 positive. Take cos to the other side, becomes cos inverse. You should be getting a y value of 23 degrees. Now remember, y 23 means this is y. The internal angle is y, but your ship is proceeding on a course like this. So you have to find out from the pole this angle here. So how do I find out? Find out the external angle first. How do I find out the external angle? 180 degrees minus y. 180 degrees minus y gives you the external angle. So 180 minus 23 will give you 157. What does 157 course mean? If I say 157, of course I can get the course by subtracting 360 from 157. I will get 203, but I also need the quadrant. So if I say this is 157 is my final course, northwest quadrant is 90 degrees, and I go further, remaining 67 degrees into the southwest quadrant. But my courses are always measured with respect to southwest, southeast, northwest or northeast. So my course will be not west 67 south, but south 23 degrees west. And that's why my final course will be 203 degrees true or south 23 degrees west. So I've got the quadrant as well. Now I've told you finding out the quadrant is very important, because initial and final courses, if they are in the same quadrant, vertex will lie outside A and B. If they are in different quadrants, vertex will lie between A and B. Now in this case, of course, both the initial and final courses are in the southwest quadrant. Southwest quadrant. If they are both in the southwest quadrant, your vertex will lie outside A and B, and vertex always lies towards the higher latitude. In this case, your higher latitude was x, 49 degrees now. So I have drawn the vertex towards the higher latitude in the northern hemisphere. Alright, this is what it will look like. Now the vertex forms a 90-degree angle, because here is where the great circle track kind of becomes a straight line for some time, and that will make a 90-degree angle with the track. So in this case, I want to find out the coordinates of the vertex. How do I do that? I will find out the position of the vertex using the triangle PYV. PYV, because I know this value as 23 degrees. I know PY as 90 plus 23, what was it? 113 degrees 01 minutes, am I correct? Yes. So I know two sides and I know 90-degree angle. That should be good enough for me. So I know 90 minus Y here and 90 minus PY. Now if you don't know how to draw the Napier's diagram, I'll show it to you. Draw a circle, that is triangle PYV. Alright, in triangle PYV, divide the first semicircle into two halves and the bottom semicircle into three. Outside the semicircle, write down the 90-degree angle. V equals 90 degree in this case. Alright, then write down the sides next to the 90-degree angle. What are the sides next to the 90-degree angle? PV or VY. You can write VY or PV, it doesn't matter. The first, when you write down PV and VY, when you write down the sides in the top semicircle, the order doesn't matter. You can write in any order. But once you write down the sides on the top semicircle, the bottom semicircle will have to go in a particular order. So when you write PV, write down 90 minus the angle the side of the angle opposite to PV. What is the angle opposite to PV? Is Y. So write down Y. Then when you have written VY, the angle opposite to VY is P. You will write down 90 minus P. So in the bottom semicircle, it will always be suffixed with a 90 minus. And finally, the remaining side, 90 minus PY. That's how I have got the Napier's diagram done. So it's always the same. Always write down the 90-degree angle outside the semicircle, then write down the sides next to the 90-degree angle first, and then in the bottom semicircle, write down 90 minus the angle opposite to the sides, and then the remaining side. Anyhow, so I know the two values here. What I have to find out is, firstly I have to find out is PV, because that will give me the latitude. I'll show you how. And I have to find out P, because this will give me the longitude. I'll show you how again. Now the Napier's rules is, using the size or using the values you know, find out the value you don't know. So if I want to find out PV and I have to use this two values, this kind of forms a mushroom shape. So that means sine of PV becomes middle part, and opposites are cos of 90 minus Y and cos 90 minus PY. This is the Napier's rule. Napier's rule. Please watch my video on Napier's rules as well. It's in the description section below if you have forgotten your Napier's rules. Now sine PV equals cos 90 minus any angle becomes sine of that angle. So sine Y and sine PY. So remember, cos 90 minus any angle becomes sine of that angle, and sine 90 minus any angle becomes cos of that angle. Now simply put in the values of Y and PY. Sine PV will be equal to 0.35963. Take sine to the other side, becomes sine inverse. You get PV equals 21 degrees. Now when we say PV equals 21 degrees, we basically mean this is equal to 21 degrees. Now of course these are not drawn to scale. But if I want to find the latitude of the vertex, then I would have to subtract PV from 90, because this is the latitude, right? So 90 degrees minus PV will give me the latitude of the vertex. So 90 minus 21 is 69 degrees north. This is the latitude of the vertex. Now if I want to find out the longitude, I have to find out P in this triangle, in the Napier's diagram. So if I erase the rest of it, so I know these two and I have to find out P, right? So how do I use it in this equation? So this is the equation it will form, right? Always use the ones that are known to you. Alright, don't use PV, because if you have made any error in PV, then you will carry the error forward. Use the ones which are initially known to you. So because here 90 minus PY is the middle part and the other two are the adjacents, the Napier's rule dictates sine of middle part, sine 90 minus PY equals tan 90 minus P equals multiplied by tan 90 minus Y, which are the adjacents. Alright. Like I said, sine of any angle becomes sine 90 minus any angle becomes cos of that angle. So this becomes cos PY, and I have taken 90 minus Y to the other side here. because I want tan 90 minus p, which is the unknown, on one side. So tan 90 minus p will be equal to cos of py divided by tan of 90 minus y. Put in the values, you get tan 90 minus p equals negative 0.16597. Take tan to the other side, becomes tan inverse. You get 90 minus p equals minus 9 degrees 25.4. Retain the negative sign, and then keeping p here, taking p on the other side makes it positive, and taking this here makes it positive. So p becomes equal to 90 degrees plus 9 degrees 25.4, where p is equal to 99 degrees 25.4. Now p is nothing but the d long between y and v. I know the longitude of the vertex, longitude of y as 41 degrees 58 minutes. I know the d long, which is the longitude between y and the v. So what I will do is here, 41 degrees 58 minutes west, the d long is 99 degrees 25.4 minutes east. So I can find out the longitude of the vertex, which becomes 57 degrees 27.4 east. How does that happen? So if I go back here, so I don't have to go back there, otherwise you guys will get confused. So you see that in the bottom drawing here, longitude of y is 41 degrees and 58 minutes, right, west. The d long between vertex and v, this value is 99 degrees 25.4. Alright, so you will go from west longitude 41 degrees, you will go all the way to the prime meridian 000 degrees. This value is 41 degrees 58 minutes west, but because your d long is 99 degrees 25.4, you will go further by a value of how much? 57 degrees 27.4 minutes, and this is in the east side. This is where your vertex is. These two values together is the d long, p in this case 99 degrees 25.4, and this, alright, so this is east. That's how it is. So you got your position of the vertex as latitude and longitude. Alright, I hope that was clear to you. Alright, then I move on and I find out the intermediate points as well. So the intermediate points, I'll just erase all this so that it doesn't become too confusing for you guys. I'll erase all this, otherwise it becomes too cluttered. So first you have to find out the longitude in which the track crosses the equator. So if I draw this diagram, the track is crossing the equator at point say M. This is where the latitude is 0 degrees. So PM will be equal to 90 minus 0, which is equal to 90 degrees. Right? PM is 90 minus 0 degrees, PM is 90 degrees. And I will be using triangle PMV. Using Napier's rules, I will draw the circle. You know how to now name it. V is the 90 degrees here. You know PM because it's 90 degrees. And you know PV, which is 21 degrees. You have found it out before when you were finding the latitude of the vertex. And what do you have to find? You have to find the longitude. To find the longitude, you have to find the d long between M and V, which is P. So this forms the equation using the ones you know and the ones you don't know. So sine 90 minus P becomes the middle part, equals tan of the adjacent values. Sine 90 minus P also becomes cos P, like I explained before. Then simply putting the values, P you get is as 90 degrees. Alright, so cos P equals 0, take cos to the other side, cos inverse of 0 is 90 degrees. Now if the longitude of the vertex is known to you as 5727.4 east and the d long is 90 degrees, again similarly your longitude will be 32 degrees 32.6 minutes west. Why? Because if, imagine this to be the longitude of the vertex, 5727.4, so you go all the way to prime meridian, this is 57 degrees 27.4 minutes east, this is 000 degrees, yes, but your d long is 90 degrees, so you have to go further by 32.6 into the west. This is M, this is west, and you have to go further 32 degrees 32.6 minutes. because all together this value together gives us 90 degrees of D long. That's why the longitude of M is 32 degrees 32.6 minutes. Alright, finally you have to calculate the latitude in which the track crosses the longitude of 010 degrees. So if I assume longitude is here 010 degrees and I will call this point N, I will use the triangle PVN, where of course vertex is 90 degrees. And what do I know in these values here? If I know the longitude of N and I know the longitude of the vertex, I will know the D long between N and the vertex, which is angle P in this case, and this angle P keeps changing depending on the triangle of course. So angle P would be the D long between the longitude of N and longitude of vertex. One is 10 degrees west, the other one is 5727.4 east. Different names, you will add the two to find the D long, therefore your D long is 6727.4. 5727.4 plus 010 degrees west. Different names add, so this becomes 6727.4. This is your angle P in triangle PVN. And of course you know PV already as 21 degrees. So PV equals 21 degrees from before, and you know angle P. So all you have to do is now find out PN. Putting all these three in the same equation, sine 90 minus P becomes the middle value, and tan of adjacents is here. Sine 90 minus P also equals cos of P, and take tan PV onto the other side, makes it division. Put in the values, find out tan 90 minus Pn first, which is equal to 0.99874. Take tan to the other side, tan inverse of 0.99874 will give you 45 degrees. 90 minus Pn equals 45, therefore Pn will be equal to 45 degrees, because once I take 90 here, you can subtract 90 minus 45. So latitude of north N, point N, not north, latitude of point N is equal to 90 minus 45, which is equal to 45 degrees. Because if Pn is 45, that would only mean this value is equal to 45 degrees, but this is not the latitude. This is the distance from the pole to the point. To find the latitude, you have to find it from the equator, like I showed you before. So to find the latitude, coincidentally of course in this case Pn equals to the latitude as well, but that's not the right way to go about it. You find out Pn first, then subtract it from 90 to find the latitude of N. And of course it's in the northern hemisphere, 45 degrees north. So make sure you guys watch this video multiple times and get an idea of how to solve these questions, how to use the Napier's rules, how to find out the longitude if you know the D long, and how to find the coordinates of the vertex. Go about it in order, go slow, don't try to go fast initially, go slow. Make sure you get each stage correct, you confirm each stage before proceeding to the next stage, otherwise you will be carrying the error forward and all your answers will be wrong. Alright, so go slow, make sure you practice this question first so that you know the method, you know the formula, you know how to apply it, you know how to calculate the values from the calculator, and then go on to the other examples. So if you have any questions, please write it in the comment section and I'll be happy to answer it as soon as possible. Bye for now.